Thank you very much, Alicia. I'd like to thank Stanford and CIS for having me. It's a great honor to be here. This talk is being recorded. There's a camera at the back of the room, and if you don't want to be recorded, try to keep your head down and don't move until it switches off. Don't say anything. If you want to ask a question without being recorded, I will hang around afterwards, and we can talk about things you might not want to have on camera. This is a series of different presentations by different folks, and Bruce Schneier is next week, and he's awesome, so you should definitely come back for that one. I'm going to try and make this presentation and this workshop as useful as it possibly can be for everyone here, but I understand that I'm not going to be able to cover 100% of your interest and your questions in the main line of the talk, so I'm going to leave a lot of time for questions at the end, and I will stick around for a while to answer other things. As Alicia mentioned, I'm Tom Lowenthal. I'm a technologist and an activist. I particularly enjoy and specialize in surveillance, self-defense, and operational security, the ways that you can avoid being spied upon, both in the technical and the practical. A few years ago, people told me that I was really, really paranoid. Now people tell me that I'm not quite paranoid enough. I don't think that I've changed much, and I think that that's really sad because I really should be too paranoid. I used to work at the Tor Project, as Alicia mentioned, and before that I was at Mozilla where I was a paranoia advocate. They still need more paranoia. I've been using Tor for about a decade, a little more. I've been contributing to the Tor network for most of that time, both just by using it, reporting bugs, trying it out on different computers, and supporting the network by running relays and so forth. I'm going to put some magic numbers on the screen. Some people may know what these are. If you don't know what they are, don't worry about it. These are my real magic numbers. If you want to, you can take a photo right now. I have them on pieces of paper later. All right. As I said, I want to make this workshop as useful for you as possible. So I'm going to ask some questions now, and I'm going to want some shows of hands so that I try to get the content right for the people who actually showed up, not just the folks who RSVP'd. Hands up if you are a student here. Great. Staff and faculty? Folks who are in neither of those groups. Awesome. All right. I see a lot of computers on desks. I did advertise that this was going to be a presentation where I would actually run through installing Tor Browser on computers. Who has a computer here that they are planning to install or debug Tor Browser on today? Okay, great. I'll spend a lot of time on that segment. Based on the computers that are out, I see that we have sort of 3/4 Mac, 1/4 Windows. Does anyone have a different operating system that they were hoping to get help on today? Android, Linux, BSD? Great. And this is going to influence how deep I go. If you think that you are not very geeky, not very technical, if you think that you are moderately technical, and if you think that you are very technical or extremely technical. All right, great. Who already uses Tor in some way? Those who have your hands up, do you want specific help because you're having difficulty, or is it actually working for you? All right, great. Let's talk a little bit about what Tor is. It was originally a project of the US Navy. It was an experiment in onion routing, which is the technical mechanism that Tor uses, and it's why the onion logo is Tor's logo. The Navy quickly realized that having the Navy Anonymity network wouldn't work very well, because whenever someone saw it, they'd go, ah, those are some Navy people talking on the Navy Anonymity network. So they published the software and the documentation and turned it over to a private organization. The Tor Project has at its core a 501c3 nonprofit that develops the software, employs developers and contractors to work on all different parts of this free software ecosystem. There are a lot of volunteers who work as well. The Tor Project does rely on individual donations to keep development going. So if Tor is useful to you, you should definitely go to torproject.org and give them some dollars or bitcoins That is directly paying the salaries of the folks who develop the software. Tor itself, in a practical sense, is a bunch of pieces of software and also a network. There are a whole bunch of computers that are connected together in the primary Tor network that is run by a bunch of people who are closely connected to the Tor project and trusted by those folks. One good way to contribute to the Tor project is to support that by adding more computers to the network. That network is running the software that's developed by the project itself. All right, let's move on to how it works. I don't want to get too far into the very technical details. I'm going to focus on what Tor Browser does and go a little light on how Tor itself works. If I'm getting too technical for you, try to raise your hand and suggest that I'm getting too technical. And if I'm boring you, just pay attention to your computers and I'll get the message. So the Tor network is a bunch of computers that are run by different people in their homes, in their businesses, in data centers. And when you try to make a connection through Tor, like when you open Tor Browser and you type in a web address, that connection is routed, instead of directly to the destination like you normally would, it gets routed through an encrypted connection through 3 of these computers in the normal case. Very clever cryptographic design ensures that all of the connections between these routers, between these nodes on the network, looks the same. So if there are 100 people connecting to the same first node that you use, and 100 connections going out, it's impractical to tell in any meaningful sense which of the connections that went in corresponds to the connection coming out. And when you do that 3 times, not only can someone watching the connections have very little idea which connections correspond, but even the nodes themselves don't have enough information to work out what you're doing. So the first node you're connecting to knows your normal IP address that you're connecting, but not what you're communicating. The node in the middle only knows the first node and the last node. They don't know who you are. They don't know what you're saying. And the node at the very end only knows the regular communication when it gets sent back to the normal internet. Doesn't have any details about who you are. Tor Browser in particular is designed for the web. The web is one particular protocol, and it has loads of ways to be re-identified on it. So Tor Browser is designed to look exactly the same. Tor Browser instances look like each other, but not a lot like other browsers. So if you're standing where I'm standing, you see lots of different faces in the room. Everyone's face looks slightly different. It's distinct and unique. That's what normal faces look like. If you all put on masks, all the same mask, I would know that those weren't regular faces, but I wouldn't know which face was which. That's basically the technique that's employed by Tor Browser, but in lots and lots of little pieces. This is the short story. Tor Browser is Firefox and Tor attached together in a very sophisticated way. When you use Tor Browser, it should feel mostly like using a regular browser, but a little bit slower, and you don't have Flash. Let's talk about what Tor can and can't do. I think this is one of the most important things that I'm going to say, because there's nothing worse than having a false sense of security. I don't want you to think that Tor can do something that it can't do, because that's the sort of situation that results in people being overconfident and getting hurt. Tor anonymizes your connection. It doesn't do anything else. So in particular, means the ISP won't know which site you're visiting. They won't know what you're saying to that site. If you're connecting on a public network like the one in here, the other people on this network won't be able to know where you're connecting to. The site won't know who you are. In fact, because all Tor Browser users look exactly the same, if you close Tor Browser and then open it again and go back to the same site, they have no useful way to tell that you're the same user they saw a few minutes ago, or a day ago, or a week ago. There are lots of things that Tor Browser can't do. It can't, in the normal use case, protect you from your ISP knowing that you use Tor. Tor traffic looks like Tor traffic. It's an encrypted connection. It's opaque. It's like wearing a mask. It's obvious that you're wearing a mask. No one knows what's under the mask, but it's clear that you're wearing a mask. The same is true for sites. They see the mask, they don't see your normal face, they know that you look like someone wearing a mask. It's very distinctive. Some sites don't like people who use Tor or provide additional rate limiting, like making you fill out a bunch of distorted text in order to use them, because they know you're using Tor. Tor Browser is just a browser. It doesn't Torify anything else on your computer. And that includes the other applications that you might use to open files you download. PDFs, Word documents, these can have web content in them, internet content in them. So if you open a PDF or a Word document that you downloaded with Tor Browser, it can connect to the internet and reveal your location on the network, your identity, or anything else that it can find on your computer. The general advice is that if you're worried about files that you download, you should turn off your Wi-Fi card. You should disconnect from the network before opening them. Tor Browser only is designed to deal with the things that it ships with. It doesn't ship with Flash because Flash is very difficult to control. It's very difficult to force Flash to connect through a proxy. Tor Browser doesn't control any other browser add-ons you might use. There are browser add-ons that will work fine. There are some really important browser add-ons that are bundled with Tor Browser. HTTPS Everywhere is designed to secure the connection between that last Tor node and the website you're using over HTTPS. But if you install a different browser add-on, that might compromise your very high level of anonymity. Tor Browser also doesn't protect you if your computer is infected with malware already. If you think that you are so interesting that spies will sneak into your house while you're not looking and put malicious hardware or software on your computer, Tor Browser will still adequately anonymize your connection, but they'll still be able to see everything that you're doing because of the malware that they put on your computer. So if you're worried about that particular use case, you maybe need to come to more of these workshops where we cover those things. So that's the short story on what Tor Browser can and can't do. I'm going to revisit some of these points later when we're talking about the install, but it's really important to know what you're not being safe against. All right. As I said, I think that Tor is very secure. Obviously, I'm completely neutral. I worked there. I worked on this project. But fortunately, you can check my work. All of the software that Tor uses is completely open. Anyone can read it, and lots of people do. All of the techniques, the cryptography, are not just made up on the fly. They're tried and tested cryptographic techniques. The sort of things that finding a vulnerability in gets you a well-published academic paper. And there are lots of academics who do write about Tor, who do analyze it, both on a large scale and each of the little cryptographic pieces that go together. And I think that those things put together, the fact that it is tried and tested cryptography, that it's open software, and that it's regularly checked by very smart people are the things that really mean that it's secure. But recently we discovered some things that the NSA had to say about Tor, and they have some really flattering things to say as well. The NSA definitely thinks that Tor is the best. So if you are going to use some anonymity system, it should be Tor, because Tor is the king. In addition, it does beat the NSA. The NSA's slides that were published in The Guardian say pretty clearly they can't de-anonymize most of the Tor users most of the time. Now, this doesn't mean that things haven't changed since then and they haven't got a better attack, or there wasn't a different secret group down the hall from the people who made this slide deck who totally did have a good attack, but it's probably a good indicator that this well-vetted, well-audited design is actually working as intended. All right. Now it's time, so if you have a laptop, you should get it out, you should get ready. Has anyone had difficulty connecting to the wireless? All right. So we're going to get started with downloading Tor Browser. This process is going to take a few minutes for most of you because you're all going to be doing it at the same time. Go to torproject.org. And in a few seconds, you can just put your hand up when you get to the torproject.org homepage so I don't go too fast. All right. Great. You want this button? And then on the download page, you want this button. Has everyone got that far? Hands up if you got that far. Is your computer downloading a thing? All right, good. Can a couple of people yell out how many minutes their computer says it's going to take to download? 2 minutes? All right. Yeah, absolutely. The question was, how do you need to change your habits in order to use Tor Browser effectively? So I tried to describe what Tor Browser can and can't do. And in terms of your habits, it's about knowing which things you do are going to give things away. If you use Tor Browser and you go to Facebook and you log in with your Facebook username and password, Facebook still knows who you are because you just told them. You just said, I am Tom Lowenthal, this is my password, you know for sure it's me. Now, your ISP doesn't know that you're visiting Facebook, but Facebook does, and they still know all your friends, and they still know all the messages that you send to your friends. So if you're worried about Facebook knowing that, using Tor Browser doesn't help. In fact, using Tor Browser doesn't help even if you act like you. If you go and you say, aha, I will make a new Facebook account, and I'll call myself Lon Toental, and they'll never guess it. But I'll connect with all my friends anyway, and I'll continue to type the way that I type, and I'll still sound like me, and I'll still act like me, and I'll still share stories about cryptography and privacy. A savvy Facebook analyst will be able to guess that that is the same person as Tom Lowenthal. Yeah, absolutely. In fact, using Tor Browser and a regular browser is a good way of having like a super private browsing mode. Tor Browser forgets everything at the end of the session so that if you close it and reopen it, it's brand new and fresh. So you might have one set of profiles that you use on your regular browser and a different set you use in Tor Browser. We might have a totally different set of activities that you do in Tor Browser. Saw another question back there? So that was a question about how many mirrors Tor has to download this software and how identifiable Tor traffic is. I want you to ask that second question again at the end because I can talk about that for a really long time. It's very interesting. The first question is much easier. There are a lot of mirrors. They're not very well advertised on the Tor Project page because if you can get to the Tor Project page, you should just use that. But the EFF runs a mirror. The Internet Archive runs a mirror. Lots of other small organizations do. And when the Tor project sees that there is a censorship event that's like that spike that they saw or things like that, they take affirmative steps to try and distribute mirror identities and other useful information for getting Tor by regular human means. All right, so is anyone still having difficulty downloading the file? All right. So for this next step, you're kind of on your own because you should have just downloaded a thing, and I want you to do with that thing what you normally do with things when you're installing them. So I think if you're a Windows user, you double-click on it, and it'll say, I'd like to extract on your desktop, and you can say yes, and then it'll create a folder. You should totally do that. And if you're a Mac user, I think you double-click on it, and then it opens at something, and you need to drag it to a different place. You should do that. It should be the normal sort of thing that you do when installing software. Anyone finding it non-obvious what to do to turn the thing they've just downloaded into installed software? The question was whether Tor automatically installs. So you've just downloaded a file. Okay. You're way ahead. That's the next slide. Tor Browser is actually designed to run in a very self-contained way. It can be installed, and you can hook it up to your computer and create shortcuts and do all that snazzy stuff. But it should just hang around in its own directory and only make changes in there and not leave traces. anywhere else. Makes it easy to put it on a thumb drive or to delete it if you don't want someone to know that you've been using Tor. That's pretty easy. Is anyone else getting a question about certificates with the Mac App Store? All right. Alicia will help you with that since you're the only one with that. Everyone else should be able to run the thing that they just did. You should get something that looks a little like this, which I think is what you were talking about. Is this what you were talking about? Awesome. Does anyone not get that? Sweet, you are the best. You're doing really well. So we are not being censored right now, I don't think, but we'll find out in a few minutes. So you should just click the connect button, and you should get one of these, except the blue bar will start off all the way over the left, and the message will change. So this is the first time you're running Tor, so this is going to take a few minutes. It's going to download a list of all of those different nodes on the network, and it's going to check that list to make sure that it's really signed by enough of the master servers to make sure that it really is a valid list. And then it's going to try connecting to some of them and building some of those 3-hop connections. And it'll take a while, but eventually you should get one of these. Hands up if you are still seeing this. All right. And hands up if you have already got here. Sweet. Hands up if you have not been able to get to here. Delightful. Y'all are the best. So once you hit this, you have a browser. This is a search box that uses start page, which is basically just Google, but through another website that doesn't remember who you are or anything like that. But it shouldn't matter because you're using Tor, so they won't even know that it's you. You can type in the browser address bar and everything else just like usual. You should at this point have it working. So now you should make sure that it does that every time, and you should close it and then reopen it again and see if it does the same thing again. Because that's how you do science. All right. At this point, hopefully everyone has Tor Browser installed and working. So I'm going to go to some questions, and I can go into more detail about any of the things that I've covered and start to do the advanced material that I have piles and piles and piles of. And while I do that, I want you to try browsing to some different sites, especially if this is the first time that you've used Tor Browser, and try to use it and see how it feels. And if something feels weird and different and doesn't work the way you expect it to, apart from the fact that it's just going to be a little bit slower because it's bouncing through all those 3 different connections, I want you to put your hand up and ask me a question about that. But in the meantime, I'm going to go to that great question that we had earlier about ISPs knowing what Tor traffic looks like, because it's a really exciting question, and this is one of the areas of most active research and development by Tor. At its core, Tor uses SSL for encrypted connections between those different endpoints. So Tor traffic looks a lot like SSL traffic. SSL is a particular standard for negotiating encrypted connections. It doesn't look much like the SSL traffic used by other applications because Tor picks its own cipher suites and has a very restricted policy about what is okay and what isn't okay and how it negotiates the sessions. But they are basically SSL connections, and they do look super distinctive. Anyone with any sort of interesting censorship infrastructure or packet sniffing infrastructure is going to know that Tor is what's happening. And that doesn't always work, because in China, if you try to use Tor, your internet connection will stop working for a few minutes. Because it looks like you're using Tor, so you're using Tor. In addition, the Tor network, the list of all the different nodes, is a public list. Anyone can download Tor and connect to one of the servers and download the entire list of all of those network endpoints. And then if you just want to block all of those, someone wouldn't be able to connect to Tor. So that's terrible. And we want Tor to work in really really angry, sophisticated censorship regimes. So we created a system called bridges and obfuscation to address the two different parts of that censorship approach. And that includes combining them and doing obfuscated bridges, which are very exciting and should be obvious when I'm finished describing. So obfuscation is about making a traffic pattern so that Tor makes a connection that looks like nothing in particular, or some particular thing that is normal. So one of the obfuscated proxies that Tor bridges are allowed to use is called obfs proxy, the obfuscated proxy. Obfs proxy just looks like nothing in particular. It doesn't look like an SSL connection. It doesn't look like web browsing, and it doesn't look like Skype, but it looks like some other application, and it's not really obvious what application it is, but it's connecting on a really high port, and that's the sort of thing that if you're a firewall administrator, you go, oh man, someone's going to complain if I block that. And that tends to deal with a lot of simple censorship that's designed to specifically target Tor, because in order to block that, you need to block everything that you don't know what it is. And most applications that use the internet, you don't know what they are. So you need to be really aggressive with your censorship and your filtering to block obfuscated traffic. But that doesn't solve the problem of just blocking the addresses of all the Tor nodes. So we use bridge nodes. A bridge node is like a fourth hop at the beginning of your Tor connection. It's an unpublished address. The bridge operator, which could be you on your home computer or someone with a big data center somewhere, submits their bridge either manually to the people they want to be able to reach it. So if you're trying to help Iranian dissidents access the Tor network and you know a bunch of Iranian dissidents and you've got a great way to talk to them, you might create a bridge and not publish it and just tell your Iranian dissident friends about its IP address, and then they can connect to it. And no one else will know that it's a Tor bridge because the connection between them and it is obfuscated. It looks like some weird protocol out there on the net. It's not obvious what's going on. The other way to distribute bridges is to tell the Tor Project about them. The Tor Project maintains a database of bridges that people have submitted. And if you go to bridges.torproject.org, you can get a few of them. And if you have a Gmail account, you can get a few more. If you have a Yahoo account, you can get some other ones. And if you can connect to the Bridges site from a totally different network, you can get a couple more. And that should hopefully be enough for most people. And Tor's been working on a sort of arms race in terms of obfuscation. There's the effort to make obfuscated connection types that are more and more complicated and more difficult to detect, to intercept, that break the previous filter that was designed to work on the previous type, or which look like a particular type of traffic. There's one obfuscated proxy that looks like you're watching a YouTube video. There's one obfuscated proxy type that looks like you're having a Skype call. There's one that looks kind of like you're browsing the web, except only thing that you're downloading is a particular book. So it's a little distinctive that way. But any type of connection that you can describe normally, we can make an obfuscated proxy type. So as long as there are some connections that are possible, Tor is always going to be able to adapt and create a new type of obfuscation to deal with that. Hopefully that answers the question in far more detail than anyone was expecting. Has anyone been having more trouble as they've been browsing around? That is not in any way surprising because it always works, and I'm really glad that it did. Are there other questions? So the question was about having to update your configuration when you move around, like when you go to a cafe or you go home or you go to the office. The answer is no. Tor is designed to work everywhere. One of the properties that it vaguely provides is censorship resistance. And because it's anonymous, that is, every Tor connection should look basically like every other Tor connection. Not only will it work everywhere, but when you go and connect to that really distinctive website that no one else goes to, but you go to all the time, or those 12 tabs you always open the first time you turn on your computer, the different networks that you go to, that's this room, that's a cafe, they won't even know that you're the same person. They'll just know that you're a Tor user. And now you've got at least a crowd of 40 who are around here. So no one will even know that it's the same person.
It's maybe more of a personal question, but mine's been loading for the past 3 or 4 minutes. Are there any tips if it's a slow connection, how to speed it up?
So the question was about Tor being slow, and Tor is slow. And when you say loading, do you mean this?
No, I mean, I'm at the congratulations page, and I enter a search query, and it's been...
And so you've got Tor Browser started, and you're trying to load a page, and it's being slow.
Yes.
The short answer is not really, and the long answer is that's one of the things that Tor's network engineers work really hard on making faster. But there is not anything that you can do to make it faster. And in fact, even if there was something that you could do to make it faster, you shouldn't do it. Because if there was something that you could do to make it faster, and you changed something so that you had a slightly faster connection, then your connection would be slightly different from everyone else's. And someone would go, oh, it's that Tor connection, but they did that little tweak that makes it look slightly different. So I bet it's the same person who used that tweak last time. So I actually suggest not changing any of the settings, but try opening a new tab. You might just have got a bad circuit. So every one of those, every website you open, you could create a new connection of 3 different proxies, 3 different middle points you need to bounce through. And some of them are slow. Some of them are slower than others. Sometimes there's one proxy that was on 5 minutes ago when the list of all proxies was there, but isn't on anymore. So you might just have got a bad connection. The series of channels that you use, it's not very good. So after a minute or two, try opening a new tab with the same thing, or try going somewhere else. Or maybe you said you were using the search bar, but it's possible to try to connect to a site that really hates Tor users because they don't really know what their threat model is, and that site just doesn't serve any content to Tor users. And those sites are jerks, and you should stop using them.
For me, I have 2.5 questions. One is, can you explain the relationship between Tor and torrents? And in particular, I was reading on the, what else can I do to protect my privacy part of the Tor browser, that if you use a torrent, you can actually de-anonymize all the traffic that's simultaneously submitted with it. Can you tell us a little bit more about that? That's question 1. Question 2 is, I just tried to log into Yahoo, and they gave me, had me do a gift challenge or a CAPTCHA, and then texted me a code. What are the web services, what are their servers seeing that makes us look suspicious?
All right, so the first question is, what is the relationship between Tor and torrents? And the relationship is that Tor used to be an abbreviation for de-onion router because of the technical mechanism. It's called onion routing. But don't capitalize all 3 letters. Now it's just Tor, capital T-O-R. And the word torrent, meaning a long stream, starts with the letters T-O-R. And that's the connection. There's no connection at all. The BitTorrent thing is particularly awkward. If you're using Tor Browser, and you're not using Tor anywhere else, but you have a torrent client because you're downloading the latest release of your software, you're fine. Don't worry about it. The problem is when you're using, when you've tried to configure something yourself, you're not using Tor Browser, you're using regular Tor as a proxy and trying to get other applications to use it. And then using BitTorrent through Tor while you're also using other applications will de-anonymize you because it creates something that looks very distinctive and it's easy to identify. And there are a bunch of articles in more or less detail. I think one of them's linked from that FAQ about why that is. But don't do that. And if you're using Tor Browser, you don't need to worry about it. Can you remind me what your second question was?
Yeah, so when I went to log into Yahoo, they gave me a CAPTCHA and wanted to send me a text message with a PIN. What are the servers seeing that makes us look suspicious?
Right. So normally web browsers are very distinctive. The web browser that you have on your computer looks very different from everyone else's web browsers. Your screen size is slightly different. You have a different combination of cookies. You load things differently. There's all sorts of different things that are very unique and distinctive. It's like your face. It doesn't look like anyone else's, except that weird person who looks kind of like you. And if you go to panopticlick.eff.org, like panopticon, but with a click, it'll tell you just how unique your web browser is. And the answer is it's probably 1 in a million. And when you normally go to Yahoo or Gmail and try to log in, they see something distinctive. And they see something distinctive every time. And maybe it's a different person because it's a different usual face because you're using a different browser, but it looks like a typical user, and it might be you. But when they see a Tor browser user, what they're seeing is someone wearing a black hoodie and a Guy Fawkes mask. That's what they're seeing. It doesn't look like a normal person. The only thing it could possibly be is a Tor user, and they want to make sure it's really you. So maybe normally they set you a cookie, and whenever you try to log in, you send them the cookie so they know it's someone who's logged in before. But now it could be anyone, and more importantly, they have no way to check up on you afterwards. Like if you are actually sneakily trying to log into someone else's account, there's no way that they could say, my, someone logged into this account and they did evil things and they were not the real person, and that's a crime, so we'll turn that info over to the police. There's no way they could do that afterwards. So they want to be really sure that it's really you. Does that answer that question? Okay.
Yeah, I was just wondering, is the IP of the final node, can it be attributed to a specific country? And if yes, which one? And in which countries are there final nodes? And can you choose your final nodes so that you could, for example, watch Netflix abroad?
Right. So the question was about what country your connection seems to be coming from. The answer is that there are loads of Tor nodes that are in loads of different countries. And if you go to a website, atlas.torproject.org, like an atlas containing a list of maps of everywhere, it'll give you a list of them, and you can search by different countries and see the breakdown. I think it's mostly American, some German, and then a gradually decreasing fraction almost everywhere else in the world, but not China. And the place that you seem to be coming from is basically random. It's random biased by the net bandwidth that is available in each country, right? Nodes with more bandwidth available are more likely to get chosen because it takes more users to fill them up. It is possible to play around with the Tor configuration and only exit in certain countries. And I don't think you should do that. Same reason that I think that you shouldn't do something even if it could make you faster, because now the circuits that you build will start to look different, and over time you start to look very distinctive, the particular pattern of countries that you've chosen. And why, in particular, do I think that you should not use it to watch Netflix? Because Tor is really bad at watching Netflix. Netflix requires a proprietary browser plugin called Silverlight, which is not installed in Tor Browser. And you shouldn't install it in Tor Browser because it's super hard to proxy correctly. And it's proprietary code, and you don't know what it's doing. So it's really hard to tell if it is proxied correctly. And also, the Tor network is kind of optimized for small things and slow things. And if you try to watch a Netflix stream, it's going to be buffering for a really long time. So I suggest that you, a little bit tongue-in-cheek, throw away your Netflix account. Stop doing that. When you want to watch media, buy it in a format where you can download it and store it on your computer without DRM. Because then you'll be able to watch it whenever you want. And you don't need to worry about which country you happen to be in right now. Wouldn't it be terrible if your laptop stopped working when you went to the UK or to Germany? That would be really sad. Why should your movies do that? The observation was that websites that work out where you're coming from and give you different content give you different content. Congratulations, Tor is working. So it should be easy enough to find the language button and switch. But in the meantime, now you're out of the filter bubble. Normally, you go to a web page and it goes, I know who you are. I think you want one of these sorts of contents. But now you get to see all the content that it's showing to everyone else. There's an interesting phenomenon that magazine covers published in the US tend to be different from magazine covers published everywhere else in the world. There's a nice little collection of Time magazine covers where when they're publishing in Asia and the Middle East and Africa and Europe about conflicts or revolutions or, news, in the US it's how do you trim your waistline or why is stress bad for you? And if you're using Tor, you might in the internet equivalent, get to see the real Time magazine cover. So I think that's awesome. I like that. The question was about if there are particular types of networks that are scary. And the answer is that there are lots of networks that are scary, but Tor is designed for the scariest networks that have ever been created. So your school or your coffee shop or your employer's got nothing on that, so don't worry about it. So the question was about using a Raspberry Pi as a Tor router that Torifies everything that goes through it. And the answer is it's totally different from using Tor Browser. Tor Browser is a really carefully handcrafted, shade-grown, really very meticulously designed piece of software that very, very carefully looks exactly the same all the time. So when you go to a website with Tor Browser, they can only tell you using Tor Browser. Now, if you created a Raspberry Pi Tor router or a Tor router using any other computer, and there's one computer that I think is the best to use for this application, it's the Novena, which is a completely open free software computer that is pretty cheap and was produced by a fantastic individual called Bunny Huang. And if you're interested in that, come and ask me afterwards, and I will never stop talking. But if you did that and use your regular Firefox or Safari or Chrome or whatever on your regular computer and you go to a website, and then you close Chrome on your computer and then you go back to that website, they know it's the same person because your browser is super distinctive. Even though the IP address has changed, all of that distinctive fingerprint that I talked about when I talked about panopticlick.eff.org, all of that stuff's the same. And now it gets even better. What if you're doing, you're checking your email over Tor and you're browsing the web over Tor and you're not really worried about the sites knowing that you're the same person, you just want your ISP not to know. And then your roommate starts downloading all the versions of Debian that have ever been published on BitTorrent. And they're trying to download a couple of gigabytes of content. Now you're using a BitTorrent connection over the same Tor node that you're using your other stuff from, and you risk being de-anonymized. So it does work. It is useful for a particular type of threat model, but at that point, everything that happens on your network is something you have to start thinking about when you think, is this going to be a problem for me? And if all you're doing is you're saying, well, I'm not particularly worried about surveillance in general. I mean, I know the NSA is watching me all the time, but I'm not really worried about it. And I'm just going to do this so that I'm in solidarity and support with all those people for whom using Tor is a really critical fact. You should absolutely do that because that's great. And it's a really neat piece of technology and it's a fun project. And it's a great way to spend a weekend. But if you're really worried about your security for all your different applications, and you're not being really careful and meticulous in deciding what to do and what not to do and how one thing affects the other thing, I think that it makes more sense to run a separate instance of Tor on each computer and carefully think about which applications you plug into it.
So just a quick plug. Peter Eckersley wrote the site that Tom is referring to, Panopticlick, and he will be here at the end of the month. I'm going to go around with more questions.
And Peter's an awesome guy.
Was the Tor network affected by the open SSL bug that was announced today?
Yes, but I think it's fixed. There is a blog post, blog.torproject.org, that says exactly how it was affected. I'm pretty sure that the short story is you don't need to worry about it too much. All of the critical pieces of Tor infrastructure were patched almost immediately. And because Tor uses ephemeral keys in memory and rotates things quickly and uses forward secret connections and all of that other defense-in-depth cryptography that's designed to make things easy, it doesn't rely on certificate authorities. My, how much easier that makes everything. It was patched pretty quickly. There are lots of Tor machines out there, and they all need to be updated slowly. But I'm pretty sure that the new network consensuses that are being produced by the master relays are taking into account which versions of Tor different computers are running and providing you with safe information. But you should check the blog for the latest information because I haven't checked it in a few hours and it keeps changing as people do more stuff. I don't think Roger has slept since that came out. Roger, one of the lead developers. Yeah, so the event being referred to is the fact that SSL, the most common form of cryptography on the web, the most popular library for it that's used in almost all applications, turns out to be a little bit broken in a way that totally breaks everything. And that happened yesterday. And people who run computers for a living didn't really sleep yesterday. The question was about malware on your computer. And the answer is, that is a whole other 4-hour presentation. I think that you should only use Tor on a computer that you know to be absolutely trustworthy. And there are none of those, so we should all just pack up and go home. But if you think there's malware, you should try to deal with the malware first, because Tor can't protect you against the malware. And if the malware is going to be circumventing the Tor, well, now Tor's only useful against the people who don't control the malware. The question was whether there are websites that provide advice and news about Tor. And the answer is that the best place to get news about Tor is the Tor Project's blog, blog.torproject.org. Every week, roughly, there is a post called the Tor Weekly News. There's also a mailing list for that if you don't want to use the web, you prefer email. And it's a rundown of everything that's happened in and around Tor in the last week. All the new developments, new projects, people, all that sort of stuff. If you're interested in news and developments on Tor, that's the best place to get it.
Final question for Tom.
The question is about one piece of Tor browser settings. I could talk about this particular topic for a really long time because cookies are one of the best ways to get tracked on the web. But I'm going to go back to my previous total cop-out answer of don't change any settings. And if you really care about it, you can come and ask me afterwards.
I'm actually going to ask one final question because I know this is a frequently asked question in other places. What is different between running Tor and using private browsing mode in another browser?
That is a fantastic question. Thank you so much for asking it, Alicia. When you use private browsing mode in a browser, the browser promises you that it won't remember anything. So it won't keep your history. It'll use a fresh cookie store and throw away the cookies afterwards. It'll do that sort of thing. The browser will not remember things. It doesn't change anyone else's behavior. Your browser still looks like your browser. It still has almost all of that fingerprint that I was talking about before. You're still making the same connection from your home on the same sort of network connection that you were using. None of that stuff is scrambled at all. Tor browser has all of the protections that you have in any private browsing mode. It has amnesia every time you turn it on, and it does all this other stuff to carefully look exactly like every other Tor browser and to make sure that your connection is anonymized in the king of low-latency anonymity systems.
Here today.
Thanks very much.